The Formula One race, one of the world's most popular sports that tests the extreme performance of the car for its speed as well as its driver. One of the most important safety parameters of this intense adrenaline rush sport is the safety of the driver while driving at unbelievable speeds. In Formula One, the unit that protects the driver is called a monocoque. Being a safety cell, the monocoque is extremely strong and stiff, and that might give you the impression that it could be very heavy. But surprisingly, it is very light in weight, which helps to keep the overall weight of the car as low as possible. This monocoque is commonly made up of carbon fiber reinforced composites, which is a type of composite material. In fact, around 80% of the components of the Formula One car make use of composite materials that help in reducing the weight of the car while still providing the desired mechanical properties. In this lesson, we'll discuss what composite materials are along with the benefits. We'll also investigate some cost factors associated with composites, followed by some of the challenges associated with composites. Ready? Let's get started. Composite materials find their use in many fields like automotive, aerospace, wind energy, sports, and sporting goods, consumer products, and so on. So what makes composite materials so special to be used across a wide range of applications and industries? Well, before understanding the unique benefits that they offer, let's first understand what composite materials are. In today's world, we have many types of materials, and these materials can be broadly classified as metals, polymers, elastomers, glasses, ceramics. And then we have hybrid materials such as composites and foams. Composite materials are materials composed of two or more constituent materials, such as the ones just listed. These are all composite materials. In the case of layered composites, which is the main focus of this course, they are typically made of multiple layers of fibers and matrix. The most commonly used fiber material are fiberglass and carbon fiber. In case of the matrix material, the most commonly used materials are thermoset epoxy and thermoplastics. Now that we have an understanding of what composite materials are, let's investigate the benefits that their family of materials offer. Layered composites have the potential to orient their stiffness and strength properties as required. Since composite materials are made by combining two or more materials, the material properties of the composite materials can be adjusted by the engineer or the material designer. In other words, the required material properties of the composites can be created just by combining two or more materials. By varying the number of layers or plies and their orientations, unique stiffness characteristics can be achieved. The stiffness in tension, bending, and torsion can all be tailored. Additionally, with composite materials, unique coupling is possible between these different modes of deformation. A part that can twist or bend when subjected to tension loads are just a few of the unique coupling that are possible. Components made using composite materials can often have significantly reduced weights as compared to metals. We saw this in the monocoque example at the start of this lesson. Also, with respect to weight, composite materials offer high stiffness and strength properties. It is important to take advantage of the composite's unique properties and avoiding loading the composites in modes of deformation that may not leverage the stiffness and strength potential of the material. Composite materials like carbon fiber can offer high fatigue resistance if they are properly designed to take the advantage of the material properties. It is also possible to create composite materials with specific material characteristics. For example, thermal stability due to the negative coefficient of the thermal expansion in the case of carbon fibers. The other benefits that composites offer are the elimination of corrosion, potential increased damping of vibration, buckling stability, and electrical and thermal conductivity or non-conductivity based on the materials used. Now let's look into the cost factors associated with composite materials. Parts or components made from composite materials are often costly because of the high cost of the raw materials and their manufacturing processes. To understand this better, let's take an example of a layered composite. The major cost of layered composite materials is associated with the reinforcement fiber. Carbon fiber, one of the commonly used composites, is often compared to metals like steel or aluminum due to its mechanical properties. However, the production of carbon fiber is very different from that of metals. Metals like steel and aluminum are obtained from raw ore, which can be directly converted into an end product or can be supplied as a raw material to be converted into a desired final shape using different processing methods. These methods involve standardized processes that are time-tested and have evolved over hundreds of years. On the other hand, the production of carbon fiber is much more involved since it utilizes mechanical and chemical processes to create long, thin strands of carbon fiber tows. These tows are then mixed with the appropriate resin matrix to create composite products. This is one aspect of why there is higher cost associated with composites. While we looked at the benefits offered by composite materials, there are various challenges associated with composite materials, and it is equally important to understand them as well. Manufacturing composite parts in high volume, like the automotive industry, is still somewhat challenging. The main reasons for this are the high cost of raw materials and the lack of large-scale manufacturing processes. Composite structures can often be repaired, but there are challenges to consider. Repairing localized damages is a complex and time-consuming process, and often requires detailed surface repair, preparation, and clean environment to bond. Also, repair processes are less standardized as compared to metal. One other challenge is the layered composites can delaminate, and that is not failure found in a metallic structure. Delamination is often hidden from sight and requires special techniques to identify. Left hidden and unchecked, delamination can grow, reducing the strength over time and leading to potential failure. Securely fastening composite parts poses yet another challenge. Traditional fastening options like rivets, bolts, etc., designed for metals are often not optimally suited for composite parts. And composites needs to be locally built up to take the bearing and fastening loads. While the need for the composite to be locally built up is a challenge, it can be considered as an advantage since local reinforcements can be achieved easier in the composite structures than on metallic structures. Just adding additional layers where needed is very common to address this. This offers extended possibilities to design lightweight structures closer to their stability limits. Another challenge is the curing of composite parts. Toughened epoxy resins are very common for high-performance layered composites, but care must be taken when curing, as during the curing process, elevated temperatures are often used, and when the composites are cooling, thermal expansion differences between the layers due to their orientation can cause parts to warp, twist, or bend out of shape. Lastly, unlike metals and other materials which can be recycled, currently composite materials are difficult to recycle. Let's summarize the key takeaway points from this lesson. Composite materials are composed of two or more constituent materials. A very common composite is the layered composite and are typically made of multiple layers including fibers and matrix materials. Composite materials offer benefits such as reduced weight, high stiffness, strength properties with respect to weight, reduced tendency to corrode, as well as other benefits. Composite materials find their application in a lot of different industries, starting from aerospace, automobile, sports, consumer products, and beyond. The major cost of composite parts is associated with the raw materials, which require more complex production processes than metals. Challenges with composites include manufacturing high volume parts, repairing localized damages, and the necessary care required while fastening composite parts. I hope you find this video informative. Thank you for watching and do check out our other courses to discover more useful learning resources.